Okay. All right. So I just wanted to first, show you what this does, so that way it will give you an idea of, why, this is related to this class. So I'll just put it on this table. Some of you may have probably seen it because you're kind of way back there, and some people may be blocking you. You can move around if you want to. And then the next thing I want to do is I'm going to upload my app onto Dropbox, because that's actually one of the easiest way for me to run my apps on the phone, because my phone already has an app to connect to Dropbox. Okay, so let's go to Dropbox on my phone. And on the app side, I go to package for phone. So instead of downloading to the phone itself, I'm downloading to the computer, to the PC itself. And once it's on the PC, I will upload it to Dropbox. So I'll start my file manager too. So this way I can just drag and drop the file. All right. And then once we are done with this little demonstration, we'll focus on 2D drawing today. So today we'll be using the canvas a lot, as well as sprites. Okay. For those of you who want to write simple games, this is one quick and easy way to write simple games. But it's also a lot more than just for writing games. You can actually do a lot of useful stuff with it too. All right. So we're just waiting here a little bit. I also spammed everybody this morning about the Pearson programming contest. Did you guys get my email this morning?
Yeah.
Yeah, about the Pearson competition or programming contest. It's the fine print, that makes it kind of like, what are they trying to do here? I'm running my little app on the robot. So, okay, since it's still compiling pretty slowly, I'll just explain how is this related to this class. When you look at the Android, the app programming interface, and some of you probably have noticed it, from day one, is there's one particular folder in the resources editor that's called Lego Mindstorms NXT. Okay. And when you open up that drawer, it has blocks or components to relate to ultrasound sensors, reflective sensors, and whatnot, which doesn't seem to make any sense at all. Because hey, we're supposed to be programming Android tablets or phones here. How do we control a motor from something like this? I don't see any connectors here that can plug into a motor. Well, what it is for is it's for programming. The Lego Mindstorms kit, which you can also, purchase. The NXT is actually the older version. I'm not sure whether, you can still buy it or not. I think if you can buy it, it's going to be either very expensive, because there are only limited number of these things, or you can buy it, less expensive if it's used already. But this thing does have motors. It has sensors. I have put two sensors on it. And I don't know why it is so slow. So let's go ahead and.
There was an issue with the build server that's saying medium to large projects may not compile or compile very slowly.
Aha. Okay.
It's up in the chart there.
Okay. I'm going to just try it one more time and. Okay, let me just kind of go through this part here. Maybe I'll show you a little bit later, when the server is not overwhelmed. So this is the drawer that I'm talking about, Lego Mindstorms. It has got these particular components. They do not run on, well, the components run on the phone, but the devices are actually on a robot, and these two are connected by Bluetooth. Okay, the robot itself is Bluetooth enabled, and most mobile devices are also Bluetooth enabled. So what's happening here is this particular app is using the phone as quote-unquote the remote brain of the robot, and using Bluetooth communication it can transmit, the phone is transmitting commands to the robot to make it move, but the sensor reading is also transmitted back to the phone for processing. Okay. Now it is interesting in it's interesting because the processor on this thing here, which is this little brick thing here, is very limited in terms of resources. Okay, it was designed in probably 4 to 5 years ago, so by today's standard, the processing power is very limited. On the other hand, your phone has the latest and greatest processors. Many people have phones now have dual processors or quad core even on the phone. They used to put quad core only on tablets, but I think on phones now too they have quad core processors. So you have tons of processing resources, a very nice user interface, and very easy to program using App Inventor or Java. And then you have something like this that is really interesting. You can do a lot of stuff with these because it really is just Legos. Okay, all the Legos that you have collected in the past 15, 30 years will still be applicable to something like this. It's just that it has added motors and sensors to the collection. And I'll give this one more try. If it doesn't work, I'll just go ahead and talk about today's topic. If it does work, I think it'll be good. Oh, okay, it's just not cooperating. I'll do this one more time, and when it's doing this, I'm going to look at today's note. And by the way, there's a homework due this morning. I hope everybody has turned in that particular program. All right. Let's go here. Oh, all right. Well, this time it's a lot faster. I think last time it's already timed out already, except it just didn't give me any.
No feedback.
Yeah, no feedback, but it's actually timed out. Okay, so let me just do this real quick so you can see the application itself. We want to go to the temp folder. Okay. So now the application is on my Dropbox account. I can open it here and install the app. Refresh.
You can also use the show barcode to get a QR code for the download link.
Sorry?
You can also use show barcode to get a QR code.
Yeah, well this one, it actually works too. Alright. Okay, so now that I have the app being installed on the phone, I can show you the interface and just kind of briefly describe what it is supposed to do. If you look at the viewer part, the viewer pane, it has two sliders here. They don't really show that well because the two sliders are supposed to be much wider. On the phone itself, you probably cannot see it, but the sliders are actually wider. It controls the motor power, so I can actually experiment with the motor, and say, okay, if I set it to 75%, power and a turn ratio of so and so, what is it going to do? Okay, so what I do is I'm going to do the latest part of the app here, which is scan. Oh, okay, I need to connect to the robot first. So the first thing I have to do is to pair my phone with the robot. And so I just pick one of the robots. If I have multiple NXT controllers, they will all show up on my list here. I just have to pick the right one to connect. All right, it's connected. So I'm telling it a command to basically turn around, but as it's turning around, it is actually collecting data from the ultrasound sensor about the distance to objects when it's turning around. And then I can click the button called stop scan, which is really just the scan button, except when it's scanning, it turns into not scan. And I can view the result using a list. So this is just raw data, so I can actually see the numbers, if I want to. And then the last part is I can touch on the canvas, and you cannot really see it, but it plots the actual distances to objects over time. Now it's only over time; it's not like a radar screen. For one reason, there's no precise way for me to tell whether it has finished one full revolution. So there's no way for me to sync the reading from one revolution to the next revolution. I can probably just give up the first revolution, but that's not what I intended to do. I wanted to actually collect data as it spins around. So that part of the logic is still being programmed. But that's basically what I have at this point. You can also just do an in-place turn, just turn around by itself. But this is not scanning anything. It's not recording anything. You can also run straight. Okay, and give it a little more space to go straight. And we can stop it. So right now, it's not doing a whole lot. But you can probably just kind of imagine, with the App Inventor interface, using the full programming blocks, it can do a lot more than that. All right, so that's my little demonstration. I just wanted to show you guys what you can do with your App Inventor programming interface. It's not really just the device itself. By the use of Bluetooth, you can actually hook it up to other devices. This is a toy. I understand a lot of times people say, well, but this is just a toy. I mean, it's not very useful. It's not practical. But you can also think about, what if you're working with industrial design? What if you're working with auto repair? Okay, what does auto repair has anything to do with this class?
Large automated machinery. Large machinery.
Large machinery. Okay. Well, does anyone repair cars? Go ahead.
Recodes memory.
Okay. Well, most cars now have a single interface to the entire computer system. Onboard diagnostic to ODB2 right now, but I think ODB2 is coming, pretty soon. Okay, so they're expanding the capability using the onboard diagnostic port. You can access every single computer. You can even reprogram a lot of the components, when you are connected to the network. Okay, so ODB2 is no longer connected to a single computer on your car. It is actually connected to an entire network of computers in your car. Okay, my mechanic has a $2,000 or $3,000 tablet thing that attaches physically, wired, tethered to the ODB2 connector. So when he is trying to fix a car or figure out why a car is not working correctly, he would drive with one hand and the other hand holding up the tablet to try to look at the reading from the tablet. Okay. Now they also sell one little device. It's called an ODB2 to Bluetooth converter. Okay. So with that little device attached, then you can become completely wireless. Okay. So everything, the interaction between your Android device or whatever device you want to use and the ODB2 part of your car can be wireless. Okay. But once it's Bluetooth enabled, you can also use, an Android app, maybe not using App Inventor, to basically interact with the ODB2 port, on the car, and therefore you can actually do your own custom programming and say, okay, for this particular trip, I just want to focus on, let's say, coolant temperature and other things. Then you can have your own special way of logging and also processing all the data. Okay, so I think the possibility completely, opens up, once you say, okay, I know the phone can only do so much, but what can it connect to using Bluetooth? Okay, a lot of devices now are Bluetooth enabled. So I just want to kind of give you guys an idea of, what you can do with that interface, just using Bluetooth. If you look at the blocks editor here, I just want to show you a little bit of the blocks editor. It has a special block, for Bluetooth connections, and it doesn't just connect to NXT devices. It can connect to any device that you want to connect to. We're still waiting for the blocks editor here. And I think one person sent me an email about not being able to see the trash can in this screen. That typically is because this screen is too large to fit on the physical screen itself, and the trash can is actually down there somewhere, but the screen is too big. So one way to do it is to change the setting. Okay, if you can see this icon but you cannot see the trash can here, go to the icon and just maximize. Well, in Windows it looks different, but if you just click the maximize option, then it will just use up to the size of the physical screen itself. Then the trash can should appear at the lower right hand corner. Okay, and this program is pretty big. I mean, if you look at the map here, you can see it's pretty big. Because I can basically zoom in and just move around, and you can see it has quite a bit of code. And this is one reason why people, professional programmers, do not like drag and drop programming, because it just takes up way too much space. Okay, and there's no easy way to scroll up and scroll down either. Okay, so it's not like when you have a text file, the relative position of all the functions are kind of fixed. This one, if you ask it to rearrange, it will rearrange and throw everything in every direction. So I try not to use that feature. What I'm talking about is right-clicking on the screen here, just any empty space. If you right-click, you will have the option to organize all blocks. Okay, if you click that and you have a lot of stuff like me, it will just end up scattering things all around in a somewhat random way. I have not figured out exactly how, what is the method of doing that, and it just makes it very hard to see everything.
I think it's the position of the corner, exactly where the one right here, the short here is right here. It goes down there.
Okay, so it's doing a zigzag.
Yeah, it looks like it just goes the y coordinate.
Yeah, but it's not logical. I mean, I cannot find related blocks. Find related.
Your definitions can be like at the end.
Is there any way to undo?
To undo it?
Yeah.
I don't think you can undo the reorganize. If you undo, it's undoing the last change to the blocks, but I don't think it can undo the rearrangement. I can do a very simple test here. See, when I move the blocks, there's no undo. I mean, the undo doesn't apply. Now, if I add a block into here, then the undo will show up to basically undo that change to the program itself. So it's kind of cumbersome. It has limitations. All right. So this is just a little demonstration, but it is related to what we're going to talk about today. If you scroll all the way down to the topic that is current, it's called drawing in 2D. We are basically drawing things in 2 dimensions. A lot of phones now have 3D, drawing capability, because the chipset they are using actually has 3D drawing capability too. But in this case, because we are using App Inventor, we're kind of limited to 2D type of drawing. And the first thing we want to do is to take a look at the canvas, because everything that we can draw is related to the canvas in App Inventor. Okay, the canvas, I'm just reading my notes here. The canvas in App Inventor is a rather complex component compared to everything else that we have talked about up to this point. A button is really simple, right? When you click it, it triggers an action, you're done. A checkbox is really simple, even though it has its own behavior, because you don't need any code to check and uncheck a checkbox. But it has a notifier, okay, or an event related to the change of the checkbox state itself. When you click on it, when it changes the state, it can trigger operations, okay? Or you can leave a checkbox, without its own code, and have like a submit button to actually process the state of a checkbox. So they're fairly simple for the most part, up to this point. But the canvas is really kind of complicated. It's because it is a self-contained component that serves both for display purposes and also for user interaction. Okay, so we are no longer looking at a particular component that can only serve one purpose or the other. Like a button, okay? Most people use a button only as a way to trigger an operation, but you can kind of use it for display purposes by changing the label, but that's not the primary purpose of a button, okay? It's just really for triggering or starting an operation. A canvas can do both. Okay? It can also interpret and report complex events like drag, swipe, and touch, okay? These are all kind of related because you can say, well, but a swipe is really a touch event, but it has certain other types of properties, and you'll be absolutely right because all of these are kind of related. All right, do we have any questions at this point about what a canvas can do, or why it is kind of different from everything else that we have talked about up to this point? Okay. If you have programmed in Scratch before, a canvas object is almost like a mini Scratch environment. If you don't know what Scratch is, don't worry. I'm not gonna, assume that you already know what Scratch is. So I'm gonna start a description of, the canvas and sprites from the ground up. It has the concept of sprites, and also the sprites also have events that relate to themselves. How many people own a Commodore 64? From way back when? Okay.
I googled it.
Okay, and on the Commodore 64, they have the concept of a sprite. This is how people wrote games in the past. Okay, everything that moves on the screen other than the background typically is a sprite. And what sprites can do is they can move on their own without any additional coding on your part, and they can detect collision with other sprites. So that's how you can write a game with a spaceship shooting an alien, and all you have to do is to say the spaceship is moving in this direction at this speed. The projectile, okay, whatever you shoot out of the spaceship is going in this direction at this speed, and the alien is moving like this. It's moving in this direction at this speed, and you don't have to do anything else. Okay, you just kind of sit around and wait. What are you waiting for? Is the projectile either hitting the alien or leaving the screen, okay? And both of those can be events that you can actually detect. In other words, the program, the environment in this case, will trigger a block to execute when a sprite contacts another sprite or contacts the edge of the canvas. At that point, you can say, oh, something happened. What happened? Okay. Then you can detect, you can say, okay, which sprite did it touch? Where did it touch that sprite? And what is the time that it is touching that sprite? You can inquire all the information. For gaming purposes, you can probably determine the score, start the explosion of the alien ship or whatever, okay? So, getting back to the notes here, the concept of a sprite is actually pretty ancient. It started, in the 70s or the 80s, probably in late 70s and early 80s, to refer to two-dimensional objects on the screen in video games that has its own ability to move and interact without you having to program and say, oh, okay, it's 10 milliseconds later, you need to go to this position. It's 10 milliseconds later, you need to move to this location. You just say, move every 10 milliseconds by 5 pixels. And that's it. That's all you have to do. And then the object will move on its own, okay, on the screen, and you don't even have to worry about, but what about the pixels that it took up before? Do I have to repaint those pixels? It's all taken care of in hardware, okay, back in those days. Do we have any questions about the introduction to the canvas? Questions? Okay. So let me go back to my app inventor screen here, and I'll go back to my project. I'm going to start a new project, just to demonstrate the canvas concept. So I'll say, this is my canvas demonstration program. And here is my normal screen. You will find the canvas up here. It is under, basic. Drag and drop the canvas into your screen, and it doesn't look like much. I mean, it looks like a little thing, under your screen. And what you can do now is to scroll to the right-hand side. You can see that the canvas is a component of your screen, and it has all these properties. So the next thing we'll do is to take a look at these properties. It's all in the notes, so I'm going to just refer to the notes here. Okay, so we have properties of a canvas. That's our next topic, which is a screenshot. It starts with a screenshot that we were seeing. We were seeing on the other screen. So we'll go ahead and talk about each property individually, and also potential ways of using those particular items. All right, so there we go. So the first one is pretty simple. I mean, it's background color. The background color is really just guess what? The background color of the canvas. You can change it, when you are just configuring in the properties. If you click on the color tab itself, you can see all the basic colors that you can choose from, from here. You can see that black, is not the default. The background color actually has a default of, white or nothing. It is only useful if you do not specify a background. Okay, if you specify a background image, then the background color can no longer be seen because the background image is going to cover the background color itself. This can also be changed in the program itself. Okay, in other words, if you want a background color to change depending on certain conditions of your app, you can do that. Now that can come in pretty handy because if you have any type of alert, you can actually change the background from a light green color, which means green is go, and you can change it to amber or yellow, for warning, and you can change it to red if there's something critical, that is, that requires your attention. So that can be useful, and you can change it in your own code, as a block. So that's color. The next one is background image. Now background image right now is none, and I don't have any choices here. That's because this is a new app. I do not have any images uploaded, to become a potential resource as a background image. If you specify a background image, then the image will be scaled to fit the entire canvas. If you upload a low resolution picture, it will be very pixelated, because it would just look really bad. If you start with a huge image, it will be downsized, to fit exactly the screen. Okay, and that can also be changed on the fly in your program. In other words, if you want to change the background image, you can do so, as a part of your program, which comes in pretty handy. That's actually a pretty handy feature. A canvas, by the way, can also save its image as a file. Okay, and that can come in very handy too, because you can basically take a screenshot or a snapshot of the canvas itself using your own logic in your app. Yep.
Can you put a button on the canvas?
Well, we'll address that. Okay, I know that's a big question, and there's a limitation, but it's easy to overcome that particular limitation. Okay? But remind me if I don't get to that part. I'm hoping we can get to that part. Okay. You have font size here. Now, why would a canvas has a font size? Well, the font size affects the text that you are drawing in the canvas. So when you draw text in the canvas, this will be the font size of that text. It can also be changed. You can change it here, when you create the object or the component, or you can change it inside your program as a block. You can basically say set font size to, and then you give it a new number, so you can basically make it bigger or smaller, as a part of your own program using your logic. So everything that we see here, every single property can be changed, by your own program, by your own blocks, which is very useful. Line width has to do with, when we are drawing a line, a dot, or a circle, what is the thickness or the width of the line? And right now the default is 2.0. If you want a thinner line, you can set it to 1, or if you want something even thicker, you can set it to 3 or more. Paint color. Now paint color affects everything that you draw or paint on the screen. The default is black, but you can change it to any one of these other colors. When you change this, it means all future lines, dots, text, and circles will be drawn in that particular color. Are we doing okay so far? And that's why it's called a canvas, okay? Because it's almost like the canvas of a painter. So when you draw something, you can select what is your paint in that case. Okay, so these are all pretty obvious stuff. Text alignment. Right now it is selecting center, which basically means when you draw text in the canvas, what you are specifying, the XY coordinate, is specifying the center of the text that you're drawing. But you can also change the alignment to left or right, in which case you'll be specifying the left corner or the right corner of the text that you're drawing. And then we have visible. Okay, it's just really controlling the visibility of the canvas. You can make it show or you can make it hide. So that part is not too mysterious. Nothing too much, nothing to really talk about that. And then we have the width. The automatic width is not that useful because it's just giving you a tiny width here, and the automatic height is also not very useful because you can see that it's just taking up this much space. When I run this app, it is going to take up only that much space. Okay, so you really want to set it to at least 300 by 300. Okay, for the most part, to make it useful. Are there any questions about the canvas properties or properties of a canvas? There's not much to it. It's almost just like any image, with some weird stuff that doesn't seem to be very useful. So we'll go ahead and take a look at the next slide here. So we have just covered this particular slide that talks about all the different properties. There's two things that we haven't talked about here. Or one thing in particular. A canvas is not a general purpose container. In other words, you cannot put a button or a text box or a label into a canvas. Okay, which seems to be a pretty bad limitation, because now what am I going to do? I mean, I can make a canvas take up a good size of my screen, but if I cannot put buttons on it, then what am I going to do to allow user interaction in that area? So we'll address those particular questions later. You can emulate buttons and other things using sprites. That's basically how we're going to do things. To do interaction, we use sprites. Moving on to drawing methods of a canvas. Okay, so this is where we can actually start to do some blocks in the blocks editor, so that we can actually test it out. Okay, so the methods of a canvas, for the most part, they're really kind of obvious. Okay, you can draw things using a canvas. You can draw a circle. When you draw a circle, you specify the center using the XY coordinate, and then you specify the radius to basically determine the size of the circle. Okay, if I just go back to this part here, let me just kind of demonstrate what I mean by that. I'm going to specify the width here to say 300 pixels by the height, which is also 300 pixels. Okay, so now I have a fairly good size canvas here. Switch to my app blocks editor screen here, and we go to my blocks, go to canvas one. Ignore everything that we see here. There are certain things that seem kind of interesting, but we're just going to go for the simple ones. We'll just use I'll use a button for now, but that's actually not needed later on. So I'll drag another button into this design so I can just trigger the operation. So I'll drag a button to the top and drag another button. The first button, I'm just going to use it to activate the action. So I'll just say do it, and change the name to and then the second button, I will use it to clear the screen, because I want to have a new screen before I do anything. So the second one, I just say clear canvas, change the name of the button accordingly. So button 2 is now clear canvas. There we go. And then we go back to the blocks editor. Now I have the two buttons. The first button is really easy. Clear canvas. When it is clicked, I will just go ahead and clear the entire canvas. So I go to canvas 1 and specify clear, and that's all it's going to do. Okay, not too much. Not too much fun here. The second button is called button do it. I will use it to trigger whatever action I want to test. So in this case, I just want to draw a circle right at the center of the entire canvas. So I would pick up your draw circle, and draw circle requires 3 pieces of information. You can see those particular sockets, right? You see a socket labeled X, Y, and R, so those will specify the XY coordinate as well as the radius of the circle that I'm drawing. X, Y, and R, they're all numbers. So there are 2 ways to do it. I can just click anywhere on the screen and then specify math. Oops, that's the wrong one. Math and a number. So I can do it this way, and then since I'm lazy, I just paste it 3 times. Then I have 3 numbers. Then I can adjust these numbers. So let's say I want it to be at the center of the entire canvas, so it would be 150. And the radius, let's say it's like I don't know, 40. Okay, so this is a pretty good size circle. I will run it inside an emulator. Are you guys starting to see how this may affect, how you write your app? Okay, whatever app you have in mind. Even if it's not a gaming app, I think a lot of apps can actually make use of the canvas for various things. We're almost there. We're just waiting for the screen to show up, and I'll start the connection. Switch back to the app, to the emulator. The emulated device here actually starts up faster than my actual phone, so the computer is pretty fast. All right. Now, because I did not specify, anything in the background, and the canvas and the background, of the entire screen, they're both, white. So we have white on white, and that's why I cannot really see the canvas itself, because it has the same color as the screen itself. So if I click do it, it should draw a circle. It is a solid block of circle. So are there any questions about this? Not very exciting. Okay. Very good. So we'll go back and try to do something that's more exciting. To move the circle? Well, to move the circle, you have to use a sprite. That's the easiest way to do it. Yep.
How smooth is the circle, or the sort of like a polygon?
It does look like a polygon, doesn't it? Let's take a look. Let's see. I suppose I can take a screenshot first and then take a closer look. So let's see if I can do it like this. Okay. Save it to the clipboard. And then use another program to open it up, and then we can zoom in and really take a look. So this is 1:1. We want to zoom in, so using the plus symbol. It's pretty round. I mean, I think it only looks pixelated, but it's not.
Yeah, there's so much information you can fit in there.
Sorry?
There's only so much pixel density it has.
Right. Yeah, but I think it made pretty good use of the available pixels. You can even see it's trying to use the gray, to make it look rounder.
Anti-aliasing.
Yeah, anti-aliasing. So it's not bad. I mean, it's doing its job. All right. Let's go back to the notes here. We have draw circle, which I just demonstrated. We have draw line. You have to specify 2 points to draw a line segment. You can draw a single point. You can draw text, which is just basically writing text on the screen. You can draw text at a particular angle. You can set the font size, so all subsequent text will use the new font size. You can set the line width. You can basically change the width of a line. You can change also the color of the paint. Okay, so it's pretty standard stuff. About using 2D type of drawing and painting. Do we have any questions about any one of these methods, or do you guys want to see a particular one demonstrated? Question?
Draw the text on the angle.
You want to see how to draw text at an angle? Okay, so you can do that. So I'll go back to my blocks editor here. Basically throw this away, and then we go to my blocks, canvas 1, draw text at angle. Okay, so just put it here. The first socket expects a text. The second one is a number. Third one is a number. The last one is also a number. The angle is specified in degrees. Okay, because App Inventor is after all intended for the general public, so it doesn't use radians, as a way to measure angles. All right, so let's go to built-in, go to text here, and just say, okay, I'll just say add an angle because it's going to be displayed at an angle. And once again, we'll center it at in the entire area. So we'll pick 150, and then duplicate the block. Let's say we want 45 degrees. Okay, so we want to slant it at 45 degrees. So change this to 45. Go back to my emulator, clear canvas, and then do it. So you can see it's at a 45-degree angle. In other words, 0 degrees means it is just horizontal the way it's supposed to, and then 45 degrees is here, 90 degrees, and you can go a full 360 before it gets back to the same orientation.
You do the same for line too.
Huh?
Same for just the line, straight line on the angle.
With a line, you don't specify the angle. With a line, you specify the first point and the second point. All right. Let's clear the canvas. Go back to my notes here. Any other method that you want me to show you? Yep.
I just have a question. What can the new draw in 3D produce?
You cannot draw 3D using App Inventor.
It's a new feature. It's been added.
Yeah, well, the App Inventor interface doesn't have the ability to draw in 3D, so you will have to use the Java code. So the next class will start to look into that.
Yeah, but what can it produce? What does one see?
In 3D?
Yeah.
It's called 3D rendering. Basically you're just,
You're just drawing a cube in 2D.
If you have 3D capability, what it is you tell the computer that the objects are at certain locations in 3D.
Oh, I see.
You tell it, the light, coordinates.
Oh.
You tell it, the light sources and your viewpoint. Where are you, and what is the width of your field, your visual field, and then it will be rendered automatically. It's just like with a normal PC. That's how 3D drawing is done. So you don't have to actually use your own code to do ray tracing and all the other stuff for 3D drawing. All right, so this part is done. So we haven't really gotten to the exciting part because the properties, they don't seem very exciting at all. Drawing methods, not too exciting. Now the exciting stuff starts when we talk about the user interaction using a canvas. Okay, and you can see that this is a much longer slide compared to the other two. Okay, so we'll talk about the events that a canvas can detect, and therefore you can associate your own code to deal with those particular events. The first one is touch down and touch up. These two are basically together because one is just sensing at which coordinate the touch starts, and then you can slide around if you want. Okay, when your finger leaves the screen, then it will trigger the touch up event, and it will report the final location when you lift your finger from the screen. Okay, so touch down is a one-shot thing. As long as you touch, it doesn't generate any additional touch down events. Okay, so if you touch the screen and you slide around like this, it's only one single touchdown. When you lift your finger, it's a touch up event, and it's a single one. Okay, in other words, if you just look at these two, it doesn't tell you what you have done on the screen. It just tells you where it starts and where it ends, and that's all. Okay. So do you guys want me to demonstrate this one, or do you think, it's okay?
Sure, demonstrate, please.
I'll demonstrate a little bit, okay? What I'll do is I'm going to demonstrate this particular event, but and have it associated with draw text. In other words, I'll have it so that it will draw the text to show you the coordinate where the touch event happened. Okay, because that's also a good way to demonstrate how do we do it. When we want open parentheses, the X number, the comma, the Y, and then the close parentheses. Okay, because we want to integrate things that are from the parameters and also things that are just fixed, which are the parentheses and the comma itself. Okay, so let's go ahead. I'll go ahead and demonstrate it like this one. So I will go to my blocks, go to canvas 1, and then go scroll up until I find touchdown. So let's say I'm just dealing with touchdown this time. Okay, as soon as you drop the block, you will see that, hey, it doesn't look like the other type of event handlers that we have done up to this point, because it has got two things. It has got X and Y, and they already have names associated with it. These are what we call arguments or parameters. In other words, they are additional pieces of information so that your script can say, oh, I want to know where the event, where on the screen or in the canvas this particular event happens. Hey, now you can refer to X and Y and know exactly where it happened. Okay. So the only thing I want to do is to use a canvas to show me, on itself, where it happened. I'm going to use draw text, not the fancy one, just drawing text without a an angle. And the X and the Y, I want to do it at exactly the same place where the touch happened. Okay, so that seems pretty easy, right? I mean, I can just drag and drop the name. No, that's not the way to do it, because the name block is really just to define the name associated with that socket. You cannot drag that one around, to refer to the value of the argument. If you want to refer to the value of an argument, you have to go to My Blocks tab, go to My Definitions, and then drag and drop these two instead, because now you're referring to the value of the argument and not the name of the argument. So now I will just drag and drop these two into here. Okay. Now before I do any more type of programming, I'm just going to finish the program like this. Attack, you're not going to display the coordinates like this. It will just say text. Well, you're right, okay, but I want to test my program step by step, okay? I want to make sure this part works first, and then I'll focus on how do I display the actual coordinate using parentheses, comma, and then the two numbers. Okay, so I'll switch back to my emulator here, clear the canvas even though there's nothing there, and I just do a one click here, because when I press the mouse button, it is emulating a touch down event. When I drag it around, and I lift the button, it's emulating a touch up event. But since I did not handle a touch up event, it's just handling the touch down event, and it worked. Okay, that's exactly when I started to press the right button on the mouse, which is emulating a touch event. Are we doing okay so far? Okay, what this is proving is at least the event happened, and the event handler got control, and I can intercept it. Okay, which is good. I'm doing it step by step. Okay, let me clear the screen again. And this time I want to change this text here and say, I don't want to just display some text. I want open parenthesis, the X coordinate, comma, the Y coordinate, and then the close parenthesis. Okay, so the question is, how do we do all that stuff? Okay, so what I'll do is I'm going to get all the components first, and then we'll talk about how to join all of those components into a single piece. There are several ways to do it. It depends on. Using join, you can do it one way, but then you have a lot of join operations. You can also use a list to do it. And so I'll do it the first way first, and you guys can see, wow, that is a lot of gibberish, just to get that done. And then we'll try the second way, to see, oh, okay, that looks a lot cleaner, okay? All right, so what I'll do is I'm just going to copy and paste, the components that needs to be displayed. Okay, so we have the X, we have the Y, and then we have three pieces of just regular text, because we have the open parenthesis. Okay, so I'm just going to copy and paste this 3 times. That's one too many. Okay, the second one is a comma, and the third one is close parenthesis. Okay, so now I'm just going to show you how I want to arrange these things. I'll just go ahead and zoom in a little bit more, and we can see better. Okay, so we have open parenthesis, we have X, we have the comma, we have Y, and then we have the close parenthesis. Okay, these are the 5 things that I want to kind of combine into my text to display. Are we doing okay so far? Is it okay? Okay. So the next thing I want to do is to say, but how do I join all of these things together? You go to built-in, you go to text, and you can see that one particular operator just kind of, it just stands out and say, use me. Which one? Join, exactly. But you can see that join also has a limitation. It only has 2 sockets, right? You can only specify 2 things to join. Then how am I going to join 5 things, right? Well, let's see. Okay, let's say these 2, are together. I guess I can use a second one to get these 2 together. And then I can use a third one. Now see what I'm doing right now? I'm using the result of one join as a part of the other join. Oops, I shouldn't be moving that one. I should be moving the outer one. Okay, and then this one can also join with this guy here. I need one more. So go to text again, another join. Take this whole complicated block, attach it here, and take this small block here and join it over here. How many joins do we have? 4. Okay, because in general, if you have n things to join, you will need n minus 1 join operators. It doesn't matter how you order it. Okay, you can order it in a certain way, you can change the ordering, you will still need that many operators. It's just like when you use addition, the plus operator. If you have 5 things to add, how many addition operators do you need? 4. Okay, so it's 1 minus the number of things that you want to add. So it's the same way here. Just going to stash it here, just so that I can test the code and see if it works. Okay, that's the first thing I want to do, is to see whether it works or not. Then we'll think about, well, that's kind of cumbersome. Can we improve it? So I'll just find a random space here to click. Okay, well, it shows 77, 127.0. Okay, that's the coordinate. Okay, it is at 77, which is the x coordinate. This is how far it is away from the left edge of the canvas, and 127 is how far down it is from the top edge of the canvas. Are we doing okay so far with the coordinate system? Yes, kind of. Okay, I can put another dot here just so that we know how the coordinate works. See, this is 166 because it's further away from the left edge, but the y is only 52 because it is closer to the top edge of the canvas. Yep.
How about point 0?
Going to 0?
Point 0. Why they show
0 will be close to here. You can see it doesn't.
Why it shows like point 0, 166.0?
Oh, why is it 0.0? Because it's a number. I have no idea. When it converts from number to text, I think it automatically appends that. I'm not.
It doesn't make sense. It's just integer.
You're right, but it's not an integer type. That's what I'm thinking. It's actually a real number type. Okay. So, do we have any questions at this point about being able to print something on screen? No questions? Okay. How many people think that this is a little bit cumbersome? Just one. Come on, you guys you have to think there has to be a better way to do this, right? I mean, this is really, really kind of cumbersome. Okay, so what I'll do next is I'm going to extract the 5 things that I want to do, that I want to join. Okay, so these are the 5 things that I want to join, and throw this away because we don't really like doing things that way. I mean, it's really not flexible either. Okay, so what we'll do is we'll go ahead and use the concept of a list. Okay, so a list is kind of an interesting thing. Well, it's interesting and not interesting in a way, because in a way it is very boring. It is just a list. Okay, how many people are familiar with the concept of a shopping list? Is that exciting? No. Well, it depends on what's on the shopping list, right? Okay, but the shopping list by itself is nothing more than a list. Okay. And it's the same way here, a list can only do these things, okay? So we can make a list, create a list. We can select an item from a list. In other words, you give it a list and you tell it, I want to get to the 3rd item, okay? And it will be able to tell you what the 3rd item of a list is, if there is such a thing. You can replace a certain item, which is kind of cool because you can say, oh, the 3rd item was cat litter, okay? Let's say a shopping list at Costco, okay? And now, your wife tells you, or whoever, wants you to go shopping, tells you, oh, we don't need cat litter anymore, but we need cat food. Okay, so this is a way to replace the cat litter with cat food, but it will still be on position 3. Yep.
Does index start at 0?
Index starts at 1.
Oh.
Remember, this is for general programming. It's not for programmers. So index starts with 1 instead of 0.
It could have went either way in my head.
With App Inventor, it really is not, like scientific or, it's not hardcore programming. So when you specify angle, it's not in radians, it is in degrees. So, that's just the way it is. This one will remove the last item. In the list, things are ordered. In other words, there's a first item, second item, and so on, and there's a last item. And the last item has a very special way to remove it. Okay? Remove the item at the specified position. Oh, remove list item. Sorry, I read it wrong. Remove the list item so you can specify which item to remove. So if you don't need to buy cat litter anymore, you can just go ahead and scratch it and remove it. You can also insert something into a list, and this allows you to insert an item to any position in the list itself. This one returns the number of items in the list. This one appends items of one list to the end of another list. Okay, so you can basically combine a shopping list to another shopping list. I'll give you an example. Okay, so let's say you have one shopping list for Costco and another shopping list for Safeway. Okay, and let's say, well, but all the items that I want to buy from Safeway, I can find those items at Costco too, and I'm running short on time, I don't want an extra trip to Safeway, then you can attach the one list to the other list, and the result is a combination of the two lists. Okay. You can add an item to a list. Oops, click instead of just pointing. So let me go back to the list here. Okay, you can also add an item to the list. We talked about that already. Oh, okay, we just talked about this one. You can ask whether something is in the list. In other words, you can search. Okay, if you have a list of numbers, let's say, you can say, okay, is this particular number in the list? Which comes in handy, but nothing that we cannot do using our own code. You can call position in list. You can this will come. It will refer back and say find a particular thing, and it will tell you where it is in the list. Not only whether it is, but it will actually tell you which item is it in the list. Yep.
Lists are kind of like a GUI array, isn't
It is kind of like an array, but an array doesn't give you the ability to insert items very efficiently. A list implies that's also a very efficient operation. But an array also, they're slightly different, but for the purposes of this programming interface, they are the same. The differences mostly have to do with the time complexity. In other words, a list is supposed to have a order n complexity to insert an item, whereas an array, well, an array is the same way too. So, but to access an item in a list is supposed to be slower to access an item in an array. But for us, we're not going to make much of a differentiation between the two.
Got it.
So you're right, it's kind of like an array.
Well, it's based on the tempo that this dynamically versus statically allocated.
Right, because a list is usually implemented as a linked list, so you have to go from one to the next to the next to the next. So if you want to access the fourth item, you have to go through the first three first. Whereas with an array, it is direct access. You just have to know where is the beginning of the entire array, and you can get to the fourth one immediately. So that's the minor difference between the two. But to this class, we'll just kind of say that they are about the same. So if you understand arrays already, a list is kind of like an array. This is interesting. Is something a list? Okay, that's what this is about. Because sometimes the variables in Scratch, not in Scratch, but in App Inventor can take on different types. They can be numbers, they can be text, they can be lists. Okay, so if you try to use a number as if it is a list, these operations will fail. Okay, when they fail, they will give you a runtime error and they say, okay, I can't move on anymore. Okay, so sometimes you want to check whether something is a list before treating it as a list. We have list to cisp362, which is very handy if you want to do any type of interaction with a web interface to a database. list to CSV comma separated value table, which is also very useful. It's kind of more advanced than what we really need to know in this case. So I'll just kind of focus on the things that I do want to do at this point. Okay, so none of these seems to be doing what we want to do. So let's go to text here, because surely there has to be something here that is useful to us. Split trim. I think it's under list. Oh, okay. CSV is the one that we want. List to CSV row. It will turn it into comma separated values. So that will take care of 3 of the items that we have, because the x comma y is comma separated value. Okay, the comma doesn't even need to be specified.
Yes.
And then we still need the parentheses. So I'm looking.
They put everything in quotes. They use quotes.
Quotes. Yeah, but I wanted to actually show the text here. I'm looking for merge, basically. Sometimes there's a feature called merge that expects a list. Contains split. It's the reverse of split. Let me see if I can find it. I cannot find that.
Make text.
Sorry? Make text. Append all arguments to form a single text string. If there's no argument, make an empty text. Yeah, I suppose that would do it. But that's not a list. Basically, you just drag each item. Every time you drag an item, it opens up a second socket. So you can just basically keep doing this until you're done. Oh, okay. I think we got that bug again. It won't attach. When that happens, just close the blocks editor and then start it over again. That usually fixes the problem. Happened to me twice yesterday. It happens usually when it's only dealing with blocks that can dynamically create additional sockets. Okay, so now we have it back. And so I need a little bit more. Okay, let's see. Yep. I can only do one at a time. No,
Very
that's kinda-
efficient.
That is kind of frustrating. That's worse than merge using a join. That's only because the program is not working the way it's supposed to. It's time for a bug report. Alright. This is kind of frustrating. Actually, I can just click this and start it. I think you guys got the idea, okay? Alright, so let's see if we can handle a little bit more this time. Yep. Maybe it has to do with the zooming too, because this time I didn't zoom. Oh wow. Well, I think that's a lot easier compared to the approach using join. So I didn't even have to use list at all, and it's still complaining about something, and that part is also wrong. Okay, it's complaining this clump contains an empty socket and won't be sent to the phone. Fine, close it again. Oh, okay, I forgot that I could just click that. Well, it's an open source project, which means if certain things is not working, I can always go look, take a look and find out why it's not working.
Still there.
Is there a concept of like a null terminator?
Hmm?
Is there like a concept of a null terminator in
A null terminator here? I don't think so. I think the last one can just be empty because if you keep attaching things to it, it will populate the next one. Okay, well, let's test it again. Just use regular text. Nope, it's still there.
I think what we did last time was delete the equivalent to the touchdown and recreate it and move everything back.
Okay. So it's the containing block that's the problem.
I think so. That's how we solved it last time.
We're starting to figure out patterns now. This one is touchdown. We did touchdown already. Let's do something else. Let's do touch up. So here's touch up. There we go. So it's not the inside block, it's the outside block. Somehow it just got the wrong information. Okay.
And you need X and Y.
Oh, that's right, because it's not the same anymore.
Does it just default to 0?
No, because when we remove this block outside of the context of an event handler, X and Y no longer apply. There's no value X and no value Y anymore. That's why it got to that.
That's not handy.
Yeah. Well, with text programming, then you don't have that problem, but you end up with other types of problems because you can refer to names that really do not exist anywhere. Then the compiler will complain and say, "Oh, we cannot do this."
No, I was referring to the call. There's an XY socket underneath the make text.
Say again?
The draw text, there's an XY as well.
Oh, that's right.
That's what I was referring to.
Okay.
Since it's not complaining, so it doesn't just default to 0.
That's a good question. Nope, it doesn't let me do it.
No.
So we do need the exit. Oh, okay. So that's what you meant when you said exit. It's still complaining. But this is connecting. Let's see whether it's actually connected. Yeah, it won't run because this clone has empty socket. It's still complaining about it. As soon as we move it out, oh, okay, good. So we still have it there. We attach. Okay, this time it's okay. This is so slow. I don't think it has to do with the communication between the PC and the emulator. It has to do with the server itself being slow. Because earlier when we tried to package into an APK file, we saw how slow it was. Okay, so let's click. Yep, it worked perfectly. Okay. So are there any questions about how to use the touch down event? This is actually touch up, okay, which means if I click on the screen and hold down the left button, I can drag it around all I want and nothing appears. But the moment I lift my finger, then it appears. Okay. Are there any questions about this part? Questions?
Is that the axis and is that the position on the screen? Those numbers?
Yes.
Okay.
The 46 is the x coordinate, which is how far it is from the left edge. The 68 is how far it is from the top edge.
Okay, I can't really read those numbers.
Yes, of the canvas to be precise. Of the canvas, not the screen.
Sure.
Of the canvas, right. Relative to the edges of the canvas. Alright, so getting back to the notes here. Alright, so we just talked about touch down and touch up. Not really exciting, except you know where the touch event occurred. Okay, both the transition from no touching to touching and the transition from touching to no touching. So those transitions can be captured. Okay, the next one is flung, because several people ask me, can I do something about the gesture to flip to the next screen using a swipe action? The answer is yes, you can, using the flung event. Okay, The flung event will capture what we call a swipe. Okay, most people call it a swipe, but for whatever reason, in App Inventor they call it a fling, action. But it's basically the same thing. The block gives you these parameters. Okay, so there are quite a few parameters here. The first two, I think, is pretty obvious. They're just the x and y coordinate of the starting point of the swipe action. In other words, it tells you where do we start the actual swipe action. The second and the third, the third and the fourth parameters or arguments are speed and heading. So these two combined will tell you, where am I swiping? Am I swiping vertically, up to down, top to bottom? Am I swiping, horizontally from left to right, or am I swiping it at an angle? Okay, so you can actually tell whether the swipe action is at an angle, so you can choose to process, different swipes to different directions, differently. It also reports the speed, which is measured in number of pixels per second. Okay, that's the measurement. I find it to be actually inaccurate. Okay, the number is a lot smaller than it should be, because when I try to swipe really fast on the screen, it still only shows about 4. Okay, and I'm pretty sure it's much more than 4 pixels per second. So I think it's number of pixels per millisecond. That's my guess. Yep.
Could it also be taken into consideration that the reporting of the screen size is different?
That could be it, but I don't think so. I think it's the number of pixels per millisecond instead of per second. So we can go ahead and so we go to Canvas, and then we go to flung here, and just take a look at the text. Yeah, it's pixel per millisecond. I was incorrect. I thought it was per second. It was actually per millisecond. So that's why it's 1,000 off from the value that I was expecting, because I was going like, wow, that should be really fast, and it only shows 4. It's like, no, it's not 4 pixels per second. It's 4 pixels per millisecond, or 4,000 pixels per second in that case. So there we have it. So we actually have the number here. All right. The next two parameters, xval and yval, are actually duplicates. In other words, if you know the heading and the speed, you can actually calculate the x velocity and the y velocity of the swipe action. It's just easier, because sometimes we only care about the x velocity, other times we want to know the actual direction. So this gives you the ability to use either one, but they're duplicate information. There's no additional information. The last one is kind of interesting. It's called flung sprite. At this point, we haven't really talked about sprites yet, but when we do have sprites, this is a Boolean value. It is a true-false value. It tells you whether a sprite was under your finger when the fling action happened. Okay, it's just true and false. It's just telling you whether you might have potentially flung a sprite. Okay. But it doesn't do anything to the sprite at all. It's just telling you whether it is on a sprite when the action happens. Are there any questions about this part? About the fling action? No questions? Okay. So for those of you who want to use a swipe action to switch to the next screen or do something similar, this is the way to do it. But the limitation is, when you use a canvas, you cannot put buttons on it. Okay, but there's a very easy way to overcome that particular limitation.
Just hide it. Hide it.
No, you cannot hide it, because when you hide it, I don't think it is active anymore.
It disables it.
Yeah, I think
You just draw.
Yep, you can make your own buttons.
Yeah,
It's like
simulate.
drawing a button.
Draw your own buttons as sprites. Then you can have your buttons moving around all the time. You can mess with people, yeah. Yep, exactly.
Download GIMP.
Yep, download GIMP and you can draw buttons in any way you want. It will even give you, the GIMP can give you a button in its depressed normal state, the press state, so it will do all the 3D effect things. It's pretty cool. Yep.
Will App Inventor support like textures on the buttons and stuff? I mean, I guess if you just
You have to get your own texture. It cannot combine stuff. So whatever sprite you have, the image for the sprite has to be preset. there's no way for it to generate the sprite or the image on the sprite dynamically, which is kind of a limitation. But it would be nice if it has the ability, but without you can still get a lot of things done. Yep.
Can you layer stuff to make a button?
Nope. Unfortunately, you cannot.
So you're pretty much stuck with an image.
You're stuck with whatever image is available as you as a resource at the time that your app is created. which I know is a limitation. It's not
You have a really large screen, then the image looks blurry, and you have a very small screen, the image looks all blocked there.
No. That's not true, because when you specify an image for a sprite, it is scaled to whatever resolution you want it. So you want to store a large, high-resolution version of the image, and when you have a smaller screen, you can always downsize it, right?
How's
You can
the
also
quality
downsample
of
it.
the resizing? How's the quality of the resizing?
I think it's reasonable. I don't think it's just picking every other pixel or something simple like that. All right. Yep.
What should we put in the do there? Do we want to switch screens or open the application?
You do whatever you want. Now, I'll just go ahead and show you how to switch screen here, but you guys can do whatever you want, okay? So I'm going to do a
We
quick...
don't have to specify the speed or the headings or any of that? Velocity?
It's up to you, okay? So it depends on whether, a vertical swipe has different meaning compared to a horizontal swipe. Okay? So that part is up to you. You can also know the speed, right? Because you know the speed of the swipe. So you can basically say, a faster swipe means something that is different from a slower swipe.
How do you set the variable for the speed?
For the speed,
Yeah.
you just get it from here. You go to, inside here, if you want to access the speed, you go to My Definitions and drag value speed into the block that makes use of speed. Okay. Is that okay?
It says it requires a name block.
No, you have to do it inside a flung block. Because the speed argument only makes sense when you're inside a canvas1.flung in this case. So you have to connect the block that makes use of speed and then drag the value speed block into that block. Okay, I'll give you.
It's not working.
Huh?
Can you drag the speed block in there so I can see it?
Okay, I'll show you a quick demonstration here. Let's say I want the screen title to reflect the speed of the flank. That's one quick and easy, dirty way to do it. So I'm going to set the screen title to My Definitions. We'll just pick up speed here. There we go. Okay. Now, when I run this app, it's going to be kind of funky because the swipe action or the speed of the swipe is now reflected as the title of the screen. But that's one quick and easy way, quick and dirty way to do it. Yep.
If you're not setting the speed, it's giving you a number on how fast your finger's going. I don't know if that helps.
Oh, okay.
The app is not holding your finger, right?
Oh, it's just telling you how fast
Yeah, it's
you
telling you
Yes.
how fast.
Yeah.
Not the action itself.
Yeah, the app cannot tell you how fast you're supposed to go. It's just measuring how fast you're swiping. So if I swipe very slowly, you will see this number decrease, like 0.27 this time, 0.27844. That's the number of pixels per millisecond. But I can do it real fast like this, and it's now up to 3.645 pixels per millisecond.
You can use those values for event handling.
You can use it for what?
Event handling.
You can use it in your own logic. So you can say, if the speed is not at least, let's say 0.5, then you do not even want to consider doing anything, just so that you don't accidentally trigger something because you accidentally touch the screen.
I don't see where to specify that.
What? You don't see what?
Yeah, the values.
The values?
Yeah, like if it was too slow, not to change the screen title.
The speed is accessed through My Definitions right here.
Right.
But you would have to do it within the flung block.
Yes, something has to be attached to the flung block already in order to make use of that value. So you cannot create a block outside and
Sure,
attach
so
it.
that'll actually put values to next.
You have to have something that is already attached to the flung block, the green one, before you can attach something that is an argument of that block to the socket that is attached. Okay. Any questions? Yep.
Can you get a? I don't think you can do it in Flung, but can you get like a real time position of the where your finger is? So
Sort of.
If you do like a loop.
Yes, you can do
detect that.
gesture. Yes, you can do gesture if you want. Yes, absolutely. That brings us to the next topic. Dragged. Okay, now drag is interesting because sometimes as you said you don't want to just a fling or spike is a linear motion. Okay, you start at a certain place, you hold the touchdown, and then you slide it across in whatever angle, and then you release your hand. Okay, but what if you want to interpret other types of gestures like drawing a circle or zigzag and something like that? Okay, a fling cannot do it. Okay, the fling action just cannot capture that. So what you need is a drag block here. Now the drag block, if you kind of read the rest here, it describes it, but I'll talk about it too. Start X and start Y is the coordinate of the entire motion. Okay, so if you do it like this, it is it's the starting point of the entire motion. That's start X and Y. What is interesting is not start X and start Y because it will stay the same no matter where you go. Previous X and the previous XY and current XY, those are the two that are interesting because what's happening here is it will break up your motion, your drag motion, into segments, and then each segment gets its own event. Okay, so now you can connect the segments because the current XY of the current event becomes the previous XY of the next event. And now you can attach those things together. Now, if you cannot process, the entire gesture in real time as it happens, you can capture those, you can capture current XY into a list. And then later on, you can look through the entire list and then process it whatever you want to, however you want to process it. Okay? And are we kind of getting this or not? You guys want me to show you an example of how to do like gesture capturing? The processing part is a little bit harder because it depends on whether you want to capture, curves and where the angle starts and stuff like that. But I can show you how to capture the points so that later on you can do your own processing. Yep.
Is there does it tell you how often it checks for the new location, like pulling rate? No,
it doesn't give you that option. You can get the time, if you want to timestamp it, you can actually get the time. That's not a part of the notes, but I can show you. If you want to capture the time, what you need to do is to include a clock in your app here. And then as a part of a clock, okay, now that I have a clock, I can capture both the time and also the location. So let me show you what I will do in this case.
Yeah, I see where you're going.
Okay, so I'll just do this one little app here. This little block here. Go to Canvas 1, go to when dragged, okay? And then what you do is, at the beginning of the entire drag action, you want to empty out the block itself. So that means, when current XY and start XY are the same, then it's not a drag, okay? I've never tried this before, so we'll probably have to give it a try here. Because I have to be able to detect the starting point of a drag operation, which is also a touchdown operation. So I think I can do my touchdown operation here first to clear the list. So what we'll do is we'll go define a global variable.
Like just ignore it if it's the distance in between is like less than a certain amount.
No, you just capture everything, including the time itself. So later on you can process that information.
I was just thinking of a way to, in case you press something and your finger moves ever so slightly, you're not actually capturing that.
But if you don't do that, then the previous XY won't connect anymore. Oh, I see what you mean. So
or
that
it just
You just
so
use the current
minor.
XY.
Yeah.
Okay, you can do that if you want to. Yep, you can, because you can process that. You just don't capture it. Okay. Any questions? Okay, the quickest way to demonstrate how to use drag is to draw a line. Okay, so we'll go ahead and just go ahead and draw a line here. When you draw a line, using the drag action, you just go to Canvas, the My Blocks, go to Canvas, and then say draw line. And then you just make use of previous XY and you connect previous XY to current XY. That's all you're gonna do. Then it will basically connect all the line segments together. So go to My Definitions, go to previous X, put it here. This is why graphical programming is kind of tedious because you have to drag and drop a lot. Nope, not start. Okay, that's current. I want current. Current X and current Y. All right. Okay. So now I have a little app that will deal with the drag operation, and I will get rid of the other one, because the same action can trigger multiple events. Okay, so you have to keep that in mind so that if you are only trying to do the drag thing, you might want to turn off the other one because they will get triggered too. I'm leaving touch up here just so that you can see that touch up will still be active even though the drag is detected. Go back to the emulator right here, and you can see how I can draw a line here. It's actually connecting segments, but then when I lift my finger, it also trigger the other operation to report the location of, because touch up is still active. So you can use a touch down to detect the start of a drag, and then use touch up to detect the end of a drag, and then use drag itself to control what you do in between. Are we doing okay so far? Sort of? Okay. Do you guys see the potential of this? Because instead of drawing a line, you can use a list to remember the positions of every single dot. Then you can do gesture recognition. You can do all kinds of fancy operation or processing on the gesture itself, and basically you can say, oh, this means what? Okay. How many people have used a Palm before? A Palm Pilot. It's a PDA. Okay. Now, the reason I mentioned that is because instead of a keyboard, a lot of the earlier Palm Pilots use a gesture to enter text. So you have to type, you have to not type, but you have to use a stylus to draw the letters in a certain way for it to recognize, the letters. And you can basically have an emulator of that, in an Android device. Even though Android devices have, on-screen keyboards, you can basically go, okay, let's, do something that is emulating, a completely out of date, device. And people do it all the time. You can find your Game Boy emulators on PCs. I mean,
Can you drag Canvas one up a little bit so I can see the bottom part of it?
Canvas one.
Very bottom of
You mean this part here?
it. Yeah.
There you go. All right. So, are there any questions? We are running out of time already, and I haven't even gotten to the most exciting part of using a canvas, which is the inclusion of sprites. Okay, because that will answer your question of how to use a button inside a canvas. Because what you do is you make a button, you turn a button into a sprite. Okay, and the sprite can change its skin. In other words, it can change its image. So when a button is not pressed, it will look in a certain way. But when it is touched, it can sense its own touch. It has its own touch event. Then you change its shape to a depressed, shape. And when you have touch up, then you change it back to the depressed state. So that's how you can emulate the effect of a button, but using a sprite inside the canvas. You can also do a slider, but when you implement a slider using a sprite inside a canvas, you have more options, because what you can do is you can do a knob too. It's not just linear. It's not just going back and forth, in a horizontal way. You can, if you want to make it, vertical, it's easy. If you make it you make it a knob, just turn it. That can also be done because everything is under your control when you use it as a sprite inside the canvas. All right. So are there any questions at this point? No questions? Okay. There's no class on Wednesday, so Wednesday I won't be here, and you guys can play with Canvas and sprites. The sprite note is already up. Okay, so that part is already up, and I'll see if I can have time at home to record about 80 minutes of lecture so that you guys can watch it instead of coming here. But the next homework assignment is going to be Canvas based, so you might want to get used to the concept of a canvas. And I think it's really flexible. You can do a lot of stuff with it. And personally, what I want to do as my project to illustrate what you can do with a canvas is a remote control car game where there'll be two canvases. The top canvas is the control, so it has a steering wheel, so you can use your finger to turn the steering wheel, and also a pedal to control the speed of the vehicle. And I have another canvas probably on top of that one to actually have a top view of a remote control car, so you can actually see where it goes. I probably don't have enough time to make the obstacles, so when it runs into an obstacle it explodes or something like that. But I'll see how far I can take it before next Monday, because that's when we'll meet again. Okay.
So what are you supposed to do?
I haven't given you an assignment yet, for your homework assignment. So I'll do that, by email.
You said we could come in here Wednesday?
No, I won't be here, so you don't want to come here.
Okay.
Yep.
Is it just you or the?
It's just me.
Okay.
I'm going to Career GPS, which is an event to advertise our program to middle school and high schooler. For those of you who are curious, or if you know someone at that age, you can see if their school is doing this. It's called Career GPS. It is held at Cal Expo. Yep, so that's it. One event, 2 days, over 7,500 students, and 175 exhibitors. I'm one of them. Capital Region High School students will navigate their futures through an interactive and engaging career fair, showcasing a broad array of career and education options. So that's what I'll be doing, is to show people what computer science is about, what we can do. And guess what? This is going with me, to Career GPS, because I'm going to use this and also the apps that I have written so far to kind of tell the students, high school and middle school students, what they can learn in computer science. I'm not going to tell them all about all the boring and the hard stuff, just the fun stuff, right? And I'll have candies ready. I think I just spent about $30 on candies to bring to Career GPS. I'm thinking that may not be enough. I already bought the cheapest candy. Well, in other words, it gives me the most individual packages per dollar, and even that is not enough. I might need another trip to Walmart.
October 10th, 2012.
October 10th. That's not the case. That's from last year. This year's this Wednesday and this Thursday. So they moved it up by 2 weeks or so. All right. So I'm gonna stop my recording, and then upload it right away.